Okay, so we are now class on example number 14. So you can see here that we are given a circuit diagram. So in this problem, we are required to solve for the equivalent resistance. So equivalent resistance, or that is the total resistance in this circuit. And then for letter A, we are asked for the current in each resistor of the following circuit diagram. So current in each resistor. Okay, so how many resistors do we have here? 1, 2, 3, and we have here an internal resistor. By the way, class, the resistor together with the battery or your source is what we call the internal resistor. Okay, as you can observe, it is just small in value. Okay, so how many currents are we trying to solve here? So since there are four resistors, which is the current moving here or flowing in our 0.4 ohm resistor, we have here the 5 ohm, the 7 ohm, and the 3 ohms. Okay, so let us name each of these resistances. Now, if you can observe, the direction or the battery is upside down, which is the positive part, or the positive terminal is here downwards, while the negative is at the top part. So this is negative and this is positive. So based from this, the direction of our current is like this. Okay, so since it is flowing in the source, so let us name it as our total current, or simply the I. Now, so going here, so at this junction, okay, so what will happen is there will be current flowing here in our 7 ohms. So let's name this as our I sub 1. And there will also be current flowing here in our 3 ohms, which let's name it as I sub 2. Okay, now how about for the current flowing here in the 5 ohms? So is it I sub 4 or I sub 3 whatsoever? So as you can observe, the path which the 5 ohms is connected to is the same as the path that our supply is connected to. So which means that the current flowing in our source is just the same with the current flowing in your 5 ohms. Can you follow? So therefore, we will only be solving here 3 values of current, which is here. Okay, so these are just the same. So it will be I sub t, I sub 1, and I sub 2. Okay, and for us to solve for that, so we will be using our principles in Ohm's law as well as in series and parallel. If you can observe, class, okay, we can observe that our circuit is a combination of series and parallel. As you can see, 7 ohms and 3 ohms are connected in parallel, while the combination of 7 and 3 is connected in series with 5 ohms, while 5 ohms and 0.4 ohms are connected in series also. As you can see, they are on the same path. Okay, so from that, let us first simplify. Let us first solve for letter A, okay, which is the total resistance. Now, in order for us, class, to solve for the total resistance or the equivalent resistance, we have to simplify our circuit, which means that we have to simplify from the outwardmost, or from the innermost part of the circuit, which is this one. This is the innermost part. So you have to combine it first before going here at the outside part, which is the one in the what do you call this, in the source. Okay, so from here, we will be combining 7 and 3. So first step is let's combine 7 ohms and 3 ohms in parallel. Okay, and let's name it as, let's say, R sub A. Okay, so R sub A is the resultant, or the sum of the 7 ohm and 3 ohm in parallel. Now, if you could recall, in order for us to determine the total resistance in a parallel, what will be our formula? If you could recall, it is the reciprocal of the sum of the reciprocals of our each resistors, which means that our formula is, let's say, R sub 1, or if you could recall, our general formula is this, like this. R sub t is equal to R sub 1 negative 1 plus R sub 2 negative 1 and raise it to negative 1. So in this case, our R sub 1 will be 7 ohms and our R sub 2 is 3 ohms. Anyway, you can interchange that. So we are trying to solve for R sub A. So from here, we will substitute. So 7 raised to negative 1 plus 3 raised to negative 1 there. And of course, the unit will be in ohms. So using your calculator, class, so we have here 7 raised to negative 1 plus we have 3 raised to negative 1 there. And then the answer will be, can you see it? There. And the answer will be raised to negative 1. And so the answer is, we have 2.1. So the answer is 2.1 ohms. Again, this 2.1 ohms is only the combination of 7 and 3. We still have remaining. So once we combine our 7 and 3 in parallel, so the circuit will become like this. Okay? So we have here 5 ohms. So since we have combined 7 and 3, so they will become 1, which is 2.1, and the circuit will look like this. Can you follow? So this is already the R sub A, which is 2.1 ohms because we have combined already A, so they become 1. And so our supply here will become negative, positive, negative, positive. So this is 30 volts, 0.4 ohms. Okay? So as you can see here, class, we now have a simplified circuit which is in a form of, or in a combination of, series circuit. Okay, where the 5 ohms, the 2.1 ohms, and the 0.4 ohms are in series. Okay, so therefore, in order for us to solve for the total resistance or the equivalent resistance in here, so we will combine, okay, we will combine 5 ohms, 0.4 ohms, and R sub A in series, and that will be our total resistance already. Can you follow? So if you could recall, in a series, all you have to do is sum up each of the resistances. So simply R sub 1 plus R sub 2, something like that, R sub 3, something like that. Okay, so in this case, we will have our R sub D. So let's have this 5 ohms plus, by the way, class, this is our general formula only. So do not refer to this because earlier we have already used R sub 1, R sub 2. So maybe you'll be confused. Ma'am, R sub 1 should be 7, R sub 2 should be 3. No, class, what I meant by this is the general formula. Okay, but what we're trying to show here is this is where we will base our computation or solving. So let us have this as our first resistor, and then 0.4 for the second resistor, and for the R sub A, we have 2.1 ohms. Okay, so using your calculator, class, so we have 5 plus 0.4 plus 2.1. So we have here 15 over 2, or that is 7.5. Okay, so that, class, is the equivalent resistance. So this is already answer, class, for our letter A.